right, it says balance the following reaction using the redox balancing techniques, which is basically a six-step process to balance these reactions. But in this case, you don't have any oxygen, so this is a good place to start. If you haven't already watched the previous two questions, please do that before you go on. So the first thing we need to do is we need to identify the oxidation states of each of the ions and atoms in this reaction. So we have magnesium, which is elemental, so it has an oxidation state of 0, going to 2 plus, and it's given to us. And then we have silver, which is plus, going to silver, which is 0. So in this case, if you remember your Leo the lion says Gur, losing electrons is oxidation. So this is our oxidation half reaction, and gaining electrons is reduction. So this is our reduction half reaction. So the first thing we want to do is, it would be like step 2, is to write the half reactions. And in this case, we have magnesium solid yields magnesium 2 plus aqueous. This is our oxidation half reaction, and our reduction half reaction is Ag plus aqueous yields Ag solid. So we break our two half reactions into oxidation and reduction. Of course, to do that, you need to identify what's oxidized and what's reduced. So again, it's really important to watch the previous videos if you're not sure how to do that. The next thing we would do is balance the mass, or balance the elements in each half reaction. So in this case, the elements are balanced. So we have magnesium yielding magnesium and silver plus yielding silver. So the elements are already balanced. In the case where you have oxygens, you'll see that in later examples, this is a lot more work. So we can essentially skip step 3. Now, step 4 is to balance the charges. So next thing we need to do is balance the charges in each half reaction. So if we look here, this magnesium yields magnesium 2 plus. So this side has a neutral charge and this side has a 2 plus charge. So to balance that out, we add 2 electrons. All right, so we add 2 electrons, and now you have 2 pluses and 2 minuses, so neutral and neutral. Note that for the oxidation half reaction, the electrons always have to be products, because oxidation is losing electrons, so the electrons have to be products. For the reduction half reaction, the electrons always have to be reactants, and this time it would be 1 electron plus the silver plus yields silver, because now we have 1 minus and 1 plus, which is 0, which equals 0 over here. Now, once we've balanced out the charges, the next thing we need to do is make the electrons even on both sides. So this would be step 5. You'll notice that you have 2 electrons here and 1 electron here. So what we need to do is we need to go from magnesium solid yields magnesium 2 plus aqueous plus 2 electrons. And this would be step 5. All right, this is all written out in the written notes, but I kind of am talking you through it instead. Here, we need to double everything because we need the same number of electrons in the oxidation half reaction and in the reduction half reaction. So we double everything. 2 electrons plus 2 Ag plus aqueous yields 2 Ag solid. Now, step 6 is we combine the two reactions together. To combine reactions together, you just write all the reactants on one reactant side and all the products on the one product side. So we end up with Mg solid plus 2E minus plus 2Ag plus aqueous. So again, all reactants, so this one and these two on one reactant side, and then all products on one product side. So Mg2 plus 2 electrons, that's these products, plus 2AgS, which is the only product over here. Now we cross out anything that's the same on both sides. In this case, the only thing that's the same on both sides is the 2 electrons. So the final reaction is Mg solid plus 2Ag plus aqueous yields Mg2 plus aqueous. I should have had an aqueous here. I had it there. I needed to have an aqueous here though. All right, plus 2Ag solid. So this is the overall balanced reaction. So again, very briefly to go through the steps, we figure out what's oxidized, what's reduced. After we do that, we balance the elements or balance the mass. Okay, in this case, we just had one of each thing, so we didn't have to do that. And then we would balance the charge by adding electrons. Note that you're balancing the overall charges, not the oxidation states. Then once we do that, we even out the number of electrons. So here we had 2 electrons, here we only had 1, so we had to double this one. Then we add the reactions together, and we cross out anything that's alike.